Hello everyone. Please join first. I'll be starting the session in 5 minutes. So we have 8 members now. Please join first. Ask your friends and colleagues to join first, and I've already shared in the group. You can also share this link to your friends and colleagues so that they can also join our sessions. I'll be starting. I'll wait for 5 minutes, and we'll be starting our session today. So especially this session is on Midas Civil, which is a excellent software uh, vastly used in the field of bridge design engineering, and you can say bridge, culvert, those kind of for these kind of designs. Mostly Midas, Lucis, then CSI bridge. This kind of softwares are used. So Midas is one of them. Okay. We have got 8 members only. Is it not the right time? Like it's 7 o'clock. So in Indian time. So I guess everyone is okay with the time because it's evening time, right? Okay, so yeah, I'll be starting the session now. I hope the screen is visible to everyone. Am I audible? Please do let me know in the comment if there is any issue with the audio and the video. I hope everything is visible properly. Okay, fine. So this is what I was talking about. This is the Midas civil software. Here you can see there is a model. I'll not use this now. I'll be showing the properties and the specifications of this model afterwards. So this is what if you open the Midas civil software, whatever version it is, mostly from 2015 to the latest version, you will find something like that only. You can download this software, the trial version of Midas civil from their website directly. It is available. So and you can practice in it. Okay. So here, if you see the software interface, it is very easy and similar to most of the softwares available in the market actually. Here you will find a file menu. If you open this, then you will be having this new project, open project, what like in typical software, in typical structural design, or maybe simple softwares that we have, maybe the Word or whatever it is, AutoCAD. So those softwares, everything, every software has this menu, right? File menu, then the quick access toolbar, then you have the main menu where all the main tools, or you can say the main tabs, will be available, and after that you will be having the ribbon bar. Okay, I don't know whether it is called ribbon bar in Midas also, but it is similar to the ribbon bar that we have in Revit, then AutoCAD and all these softwares, right? So here under this main tab, if you see, there are different components, and if you click on any of this component, whatever required as per this particular name, you can see the structure. Okay, so whatever we require to create a structure, then you will be having everything here in this ribbon. Okay, suppose node and elements. So if you want to create or delete or edit any node or elements, then you will be having this, right? Same, any property, whatever it is, material property or maybe section property. Okay, and to edit these properties, you'll be having this tab. So it is very simple, as simple as we have the AutoCAD, ZWCAD, whatever CAD software or structural design software it is. Okay. Now, then we have boundary. Boundary is nothing but the boundary condition. That means the springs you are going to assign, or maybe the support condition that you are going to assign. Okay, the joint condition. So everything is available in the boundary main menu. Okay. Then we have loads, the analysis, results. Okay. Specifically, as this Midas civil software is mostly used in the field of bridge design engineering, then here they have some specific tabs like the PSC. Okay, pre-tension concrete, right? So this PSC, if you see here is a different tab, a separate tab for PSC. Then we have the pushover analysis, a separate tab for pushover. Then we have design rating. This rating term is used in bridge design actually. Then we have the query and tools. Okay, so these are not required that much, but up to here, up to design and rating, you can say all this will be used in if you are designing a bridge or if you are designing a bridge like structure, maybe the culvert or something like that. Okay, you can also model building here, you can also analyze buildings here. There is no no such provision that you cannot model or you cannot design it here. It is possible here also. Okay, but specially they have a separate software for building, which is maybe Midas Gen or Midas Engine. So this software is specifically built for designing the buildings. Okay, and this Midas Civil is specifically built for designing bridges, or you can say culverts like that. Okay, why it is why I'm saying like specifically, because here if you see in the analysis load tab, we have this moving loads. If you see here PSC, we have a separate part or separate tab for creating that PSC girders, right? If you go to structure, you can see we have different kind of bridges. Okay, ILM bridges, FCM, then maybe RC slab bridge, RC frame or box type of structure like this. Okay, so and then we have this composite steel bridge, pre-stressed composite bridge. So these options are available in this particular software. That's why you can say that this software is specifically made for designing the bridges. I hope it is clear to all of you. Okay. Now, here we have some commands. These options are for selecting the elements. You can see here a group. Then you can toggle workspace. Then we have select single element, or select by window. You can say select by polygon. Okay, select all. So there are some options here, and here we have some options for viewing. You can say active means you can select any member. I can select you can active the view for that particular member or particular element. Okay, then we have some inactive. You can inactive some elements from here, from the view. Okay, we have shrink, means you can shrink the view. If you click on this, you can see everything will be separated. Okay, just let me remove the loads. I think some loads I have, it is lane, right? Okay, traffic lanes and display. Yeah, so you can see here, if I click on this, yeah. Okay, so this is the work of shrink. It is also there in ETABS also, right? Then we have perspective view. If you want to see the perspective view of the structure. Okay, here we have some hidden view, you can see, and we have some display options, like you can set your display options as per your requirement. Okay, and here also some tools are available, like zoom and zoom in, zoom out. then you rotate. Okay, you can also see the redraw. This is the view options, view commands are there. Okay, you can also change the parameters, or you can say the units of your display or units of your assignment, some loads, or maybe the movements, whatever it is, units you can change here. At any time you can change the unit, and it will convert the value as per the selected unit. Actually, suppose you have assigned the loads as on using the kilonewton unit. Okay, and now you have changed it to newton and meter. Now it will, every load or every value that you have assigned here, it will be converted to newton. Similarly, in case of the length also, suppose you have assigned as meter, but you have changed it to centimeter afterwards, so all the values will be changed to centimeters. Changed means it will be converted to centimeters. So this is the beauty of this software. You do not have to worry about changing the units, and maybe you will be doing some mishaps. No, it will do by itself. Okay, now, okay, let me start a new model. For that, I'll click on here, file, and I'll click on new project. So this is my new project. If you see the top view, here you have this box or cube like that. If you go to top view, here it is the top view. You can also see some orthographic views. Okay, front view, side views. Now let me start from the very scratch. Suppose you want to create some nodes and some elements here. Okay, for that, okay, let me before going to nodes and elements, here you have this particular window, which is nothing but your tree menu. Okay, so in tree menu, those who have used eTabs, we have the model explorer, right? So it is similar to that model explorer. Actually, every information that you are giving here in this viewport, or you can say this area where we are creating the model, so all the information will be available here in terms in a form of you can say tree. Okay, so if you go to works, here you can see there is no work now because we have not created anything. Okay, so these are the tables. You can see if you have created some groups and report, so it will be there. Fine. So this tree menu, you can also create another tree menu here. If you right click in this area, you can see tree menu 2. So same tree menu will be available in the right hand side also. So you can close this also if you want, or you can keep both. Maybe you will be doing some work, you need to check the loads in this side, and you need to check the elements in this side. So you can keep 2 tree menus. This is totally up to you as per your you can say comfort. Okay, now suppose I'll be creating some nodes and elements. Okay, so before creating some nodes and elements, suppose I'll be creating a concrete structure. I'll also show how to create a 2D and 3D frame here. So just to start from the basic, if you go to nodes and elements, here you have option to create nodes and elements. Okay, so before going to that, I'll define some material and section properties. I'll go to material properties, add, I'll change it to concrete, and maybe here standard I'll select, you can say ISRC. I'll be creating one reinforced concrete structure. Okay, so here I have ISRC. Now all the parameters according to the ISRC, if you select, suppose I'll be selecting M25, so all the parameters as per M25 grade of concrete will be defined here. Okay, now if you want to define your own properties, or maybe something that you want to define from the design, maybe design mix, then you just have to go to none, and you can define all these values by yourself. Okay, so now I'll select ISRC, and here M25, I'll click on OK. Here you can see one material ID is given, which is ID 1. Okay, now click on OK and close. Now I'll define one section. If you go to section properties, add, here also you can see there are different sections. Okay, you can see PSC girders, you have different types of PSC girders. You can always define this. There are variety of structures, or you can say bridge, especially for bridge. You do not have to model manually, everything will be available here. Okay, so you do not have to, so you can see the PACT, then we have PAC 3 cell. Okay, so you just have to give the parameters here, and you can automatically get the model ready. Okay, so now initially I'll go for db user and I'll change it to maybe a solid rectangle. Okay, here I'll make it is, and you can see, do we have any isrc or something like that? No. Okay, I'll select as is. You can also make it user. Okay, I think it is better to make user because we'll be creating yeah, we'll be creating the model which is not assigned to these properties, right? So I'll make it user. Now height, maybe I'll keep it 450, and the, okay, it is in meter, right? So 0.45, and the width I'll be keeping maybe 300, so 0.3. Okay, so we have got this rectangular section. Click on OK or apply. So what is the invalid section name? Okay, this section where we have, okay, section name. Let me write it here, maybe, or the S300 by 450. I'll be using the same section for beam and column. So I have given a name which is S300 450. If you want, you can make a beam separately and the column separately. Okay. So just to show you, I have assigned one particular section. Click on OK. So we have defined the section, right? Click on close. Okay. Now I'll go to nodes, and here I'll create one node first. So I'll select here create node. Now at what position you want to create the node? Obviously it is 0, 0, 0, 0. That means this particular position, the initial position. Number of nodes you want to create, suppose I want to create 5 number of nodes, and this is my x direction, right? So yeah, you can create here. You can just put the value dy. Okay, I'll be keeping it as 5. That means every node will be created with 5 meter of, or maybe 4. Okay, so 4. Now number of nodes maybe 5 or 6. Okay, so 6 nodes will be created, and the distance between these nodes will be 4 meter along, sorry, it will be along x direction. So along x direction you need to give the value. So 4 comma 0 comma 0. Okay, so this is how you can define the spacings. Okay, now click on apply, and here you can see along x direction we have these nodes. Now you can close this. So now suppose I want to create some nodes here in the along y direction. So for that, what I'll do, I'll select this single selection, or maybe select by window. I'll select all the nodes, and here we have this option called translate. Okay, translate, and here we have copy. What you can do, I want to copy along this direction, y direction, right? Now you have two options. If you want to create equal distance, you can select this, and if you want to create unequal distance, you can select this. So one by one you will be creating the unequal spacings. Okay, for now I'll be creating one equal distance, and along y direction I'll keep the spacing as maybe 3.5. okay, number of times maybe 7. Fine, and click on apply, and here you can see we have created these nodes. Okay, now there are different options, or you can say different process to create uh, the elements, maybe the beams. So I'll show the simple process. If you click on create element, you can just create the element from node to node, maybe from this node to this node, again from this node to this node, like that. Okay, let me just control Z, or else see here the elements are selected, right? 300 and 450. So automatically it will be assigning to these beams. If you have two elements, you can select among these two which one you want to assign to the beam that you are creating. Okay, so this is the one process. Let me create the whole beam here. Okay, so this is one process. You can create beam like this from node to node. Another process is maybe I'll select this node. select single node. I'll select this particular node. Okay, and we have this extrude option. You see extrude elements. Okay, if you click on extrude, and from where to where you want to extrude this node, and there is one option. If you click on extrude, there is different options. Here you can see node to element, node to, you can say line element to planar element, or planar element to solid element. Okay, so from a node you can create an element, from a line you can create a plane, and from a plane you can create solids. Okay, so now we have a node and we want to create the elements, line elements. So you can select this, and here if you click on this box and go to this node, you will see that you have this arrow, means from which this node to which node you want to create and in which direction. You can go either in this direction or in the y direction. So I'll click up to this and I click on apply. And you can see this node will be extruded from this point to this particular. Okay, so similarly I'll do for all the nodes. Just have to select all these nodes. Okay, the same, sorry, it is asking me to save, so let me save it, maybe demo 1. Yeah, so now just select here, and from this node to this node. Okay, click on apply. You can see all the nodes we have extruded to elements. Similarly we'll do for the either the another side. So I'll select these nodes, select by window, maybe I'll select all these nodes. Okay, I'll go here, and from this node to this node, and click on apply. So we have created a grid of beams. You see here we have the isometric view. You can see the isometric view, or maybe from here. Okay, so this is how we can create the grid of beam. Now it is very easy, right? In StatPro or maybe in some other softwares like Strap, we used to create models using nodes and elements, right? So here, if you want to create simple elements or simple maybe some simple structures, so you can create using these nodes and elements always. Okay, and maybe some structures or some structural element that you do not have here automatically to create automatically, then you can create using these nodes and elements. Okay, so if I create a whole building, let me just go to the top view. So what I can do, I can select the whole structure like this, and I'll do the same. I'll just translate it. So what I'll do, I'll translate the elements. Now we have under these elements, we have this translate, and I want to copy along Z direction, right? I think here it is not Z. Let me go to isometric view. Here it is XY, yeah, Z direction. So along Z direction, maybe 3 meter. How many copies? Maybe suppose 9 copies or 10 copies. Fine. So we want 10 copies and click on apply. You can see 10 copies or 10 floors we have created. Now how to assign the columns? Suppose you do not want to assign columns to every single node. Okay. So for that, I'll go to the front view of the structure. Now I'll select this particular floor, and here we have option to active this floor. So active. Now only this floor will be active. If you go to top view, you can see this floor is active now. Okay. Now I'll select some nodes here, some individual nodes, maybe this node, all the four corners, then this. Okay, maybe here also, and in between the same way I'll be selecting the columns, maybe, yeah, here. In the other direction, yeah, let me select all these. Fine. So I have selected in here also. I'll select one just for showing. Okay, so I have selected these nodes, right? I have selected these nodes. Now I'll go to isometric view, and here we have active all. Okay, we have activated all the whole structure. Now I'll go to nodes and elements, and here again I'll use this option which is extrude. So if I click on extrude, I want to extrude the nodes that I have selected to elements, right? And the element section I'll be selecting. Suppose you have assigned a different, or you have created a different section for the columns. Okay, let me define one maybe. Add or copy. Yeah, copy I can make. Copy, and I'll modify this. Maybe I'll modify this to 450 by 450. Okay, I'll change this to 450. Fine, click on OK and close. Similarly, you can do the same for this material also. Maybe I'll change it to M30 now for the columns. Add will be ISRC, where it is. Sorry, change it to concrete ISRC, and I'll change it to M30. Okay, close. So here for creating the columns, what I'll do, I'll change this to M30 and this section to 450 by 450, which is our section 2. Fine, and I'll use the extrude option. So I'll click on here, and from this node to the top node. Fine, and click on apply. Here you can see how easily we have created the columns. Now if you go to the front view of the structure, I think this is the front view, right? So you can always delete this. So what I'll do, I'll use this here. I'll be deleting maybe the elements. Here you can see we have delete option here. Delete. I'll use this one. Select these elements and click on apply. So now the similarly I'll do for the nodes. Delete and apply. Okay. Now if I go to the isometric view, here we have created the structure. Though it is not exactly made for designing the buildings or modeling the buildings, but we can do everything in civil, Midas Civil actually. Even the same thing you can do in Midas Gen. In Midas Gen you can create the bridges. In Midas Engine also you can create the bridges and buildings. So in every software that Midas have developed, similarly in ETABS, if you see, in SAP 2000, in CSI Bridge, in SAP 2000 we can model the bridges, right? We can design the bridges, but again we have a separate option like CSI Bridge. So similarly in Midas also we have separate options, but specifically there are some tools which are used for the bridge design, which is available in Midas Civil. I hope it is clear to all of you. Okay, so now you can always assign the support condition. If you go to the front view of the structure, okay, select all the nodes. Let me go to here. Yeah, select all these nodes. Now if you go to boundary, here we have defined supports. Okay, let me define. I think we have some supports which is predefined. Let me see if it is there. If not, then you can always restrain all these. D all, R all means displacement all and rotation all. Okay, and you can click on apply. So it will be assigned to all the nodes present here. Let's see. So we have made it fixed, right? So this is how we can model from the scratch using the nodes and elements. And there are different other options. You can always use these. You can see map, mesh, auto mesh. Okay, define domain. Actually, these are for the slabs. Actually, you can create the slabs also here, and you can mesh it, and you can define some domains. Now, what is domains? I'll explain in some other session actually. Okay, fine. I hope it is clear up to this, all of you. Now what we will do, we'll create a 2D and 3D frame. Okay, maybe in terms of, you can say, the culvert, and I'll show you how you can do it very easily. So for that I'll just save it. I'll take a new model, new project. Now here if you go to the structure wizard, you can see there are different options to create different kind of bridges. Okay, now to our concern is to create some 2D and 3D frame in terms of box culvert, or you can say in terms of designing the culvert. So if you go to RC frame or box, here you can see this wizard will help you to create 3D and 2D frame or maybe box culvert. So first of all, I'll create 2D frame. For that, I'll go to 2-dimensional. Okay, now the material I have not defined here. So if you click on these 3 dots, here you can add. I'll change it to concrete, and you can select the standard and maybe M30 grade. Okay, click on OK. It will be added. Close. Fine. Now you can define different spans. Maybe if you have different spans, different span values, then you can always write maybe 6, 4, like that. But now here, I will create 2 spans of maybe 7 meter. Okay, so 2@7. You can also always define like that. Okay, if you want to create some shape variation, you can always check in the shape variation, circular or polynomial type. Okay, but I do not want this now. See here we have some pie type frame also, we have box culvert also. Okay, so now I'm not going for box culvert. I'll be creating a normal type frame. Here there are different values. You can see T1, this T1, okay, A2, the thickness, this horns distance. So all these things you can define. You can always give these values. If you go to the transverse, this is my longitudinal definition. Okay, now if you go to transverse, here you have different kind of decks actually. Here in the both the sides we have the pedestrian area, and we have this barrier, crash barrier. If you select another one, type 2, here we have one crash barrier. In the other side we have the pedestrian and crash barrier. In the type 3 we have in the right left hand side we have this crash barrier, and other side we have the crash barrier and the pedestrian both. Okay, so you can always select any of them. Maybe I'll be selecting the type 1. Okay, both the sides will be having the same thing. You can define the length of the pedestrian area, okay, which is our B4. Where is B4? Yeah, here, B4. So you can suppose I'll be making it 2 meter. Okay, the thickness of the crash barrier you can define here, which is B3. I think, yeah, B3. Maybe I'll make it 450, and B7 also 450 I'll make. Then we have B6 and B4. Okay, B6 and B4 I'll make 2 meter. Fine. And in between, maybe I do not know. I think we have created a longitudinal area of 14 meter, right? So maybe in between B5 we have this, right? B5. So already we have taken 450, means 0.9, 4.9, right? So what will be the value here? 4.9. If I calculate from 14 minus 4.9, so it will be 9.1. So you can keep this B5 value as 9.1 meter, right? Now just click on OK. Okay, if you go to loads, then you can see here the self weight of the structure, the self weight of the pavement. Okay, if you see here, let me go to longitudinal value. Here always remember this P1. Here you can see one value which is thickness P, and another thickness we have H2. Suppose if you have soil filling above your maybe the frame, or you can say the box culvert. If you have soil filling, after that if you have the pavement, then you can keep this, you can put this H2 value. Otherwise, if you do not have any, because this H2, if you see, it includes the value of P. It includes the value of P here. That means H2 is nothing but the soil filling plus the height of your pavement, or you can thickness of your pavement. Okay, so now if you do not have any filling material, or maybe do not have any filling soil, okay, here, so always remember, keep this H2 and P value same. This H2 and P value same. Okay, that means this is nothing but the thickness of your pavement. only the thickness of your pavement. Okay, so if you go to loads, this thickness, according to the thickness and the density that you are providing for the soil and the pavement material, and also the concrete material. Okay, so the pavement and soil, concrete already we have defined. So according to the thickness and the density, it will be calculating the self weight of that material automatically. Okay, for this structure, we will not assign any surcharge load, that means the extra load. Okay, fine. We have the phi value, that is soil friction, right? The friction coefficient, sorry, the friction angle. So you can provide this friction angle from the geotechnical report. Then we have the barrier. So we have provided for 0.45, right? So accordingly, it will be calculating the self weight of the barrier. Similarly, for the sidewalk also, that means the pedestrian area. Now these values you can always consider as per the code that you are using. Maybe for India we'll be using IRC, right? So IRC 6. So you can always consider these values. This temperature gradient we have in the IRC 6 page number 55. You can define from here, and this temperature, so the system temperature and the temperature gradient you need to calculate actually. Okay, so it is all these values are there, all this process of defining, or you can say calculating these values are there in ISC 6. You can always read this code to define these values. Okay, so for now I'll be going with the default values, and the load combination though we do not need now, but you can always select IRC 6, and moving loads I will not define now. Just for the load combination, if you are using IRC 6, you can select the IRC 6 2000 from here. Okay, now click on OK, and here you can see a frame, a 2D frame with two spans of 7 meters that we have created. Okay, this support condition also provided here. For that, if I go to display option, I think it is there, boundary. Not here. See to here. Nodes. Yeah, boundary. It should be showing actually support line. Yeah. So you can see the support condition that we have assigned. Okay. So this is how it was actually there. If you see in the transverse, here you can see the support of the culvert, support of the pi frame. Okay, whatever frame we have selected, so it will be assigned here. Okay, here transverse fixed support we have assigned. Fine. Okay, so yeah, the support is assigned, the frame is created, and also all the loads that we wanted, as we are considering this as a part of a culvert, okay, or part of a box culvert you can say, but we do not have, it is not a box culvert because we do not have the bottom slab. Okay, so all the loads, maybe the soil load, soil pressure, okay, that the pressure due to the pavement, everything is assigned here. Now how to check those? You just, okay, Mr. Manu, please go to the website of Midas, okay, and there you will be having the trial version for all the softwares. Actually, you can always download from there and you can practice. Okay. Okay, so now to check the loads here, whatever the loads that is assigned here, the loads we have assigned, right? You go to the frame box, loads, all these loads that we have assigned, and we also assign the soil load. You can see the soil density we have assigned, right? So it will be there. If you go to the tree menu and works, you can see the properties. We have assigned material 1, which is M30. The section, you can see there are sections divided in different elements, small elements, right? You can select from here, you can see the element. Means this meshing has done automatically. Okay, and you can see the supports. Okay, you can see here different elements for beams. And if you want to, if you talk about the loads, then you can see the dead load, self weight. Yeah, if you right click on element beam loads, right click and display, and you can see the loads assigned. The temperature gradient. Okay, let me save it now as maybe 2D frame. sorry, 2D frame demo 2. Now here you can see the temperature gradient. Right click display, it will be showing you. As it was assigned as 5, so all this 5 value is assigned to all the elements, right? Okay, display at the top and the bottom. Means what is the difference of temperature at the top of the section and the bottom of the section? Obviously there will be a difference, right? Because this top is exposed to the weather, or you can say exposed to the sun. Maybe the bottom is not that much. Okay, so there will be a difference, right? So you can always define it actually, as I have given actually the similar value, but you can always define or calculate it auto. Now if I go to here, water load, right click display, you can see, is it water load or water, yeah, okay. And we have, no, this is not water load actually, this is soil earth pressure. We do not have any water load, we have not assigned any water load, this is nothing but the earth pressure. So the soil, if we have a soil this side, so this soil pressure is showing here, okay. If you go to here, the shrinkage load display, so these things you just have to consider the code that you are using. From there you can, and here we have the crowd load, right? In the beside the crash barrier we have the sidewalk. So if you right click display, you can see the crowd load. Fine. So this crowd load is given here. So this is how we can create one 2D panel. Now you just have to do analysis. If you go here, perform analysis, it will be performing the analysis. So the analysis is done. Now to check the results, you just have to go to results, or if you go to analysis here, you can see there are different control data. Now let's check these options. So maybe the P delta, the buckling, the eigenvalue, means for the model analysis you can define these moving loads. Okay, now I'll check the results. Now first of all I'll show you the reactions. Okay, for that if I go to reactions and maybe reaction forces and moments, maybe I want to check the FZ. Fine. And now FZ due to dead load, maybe, yeah, apply. Here you can see the dead load, the reactions due to dead load, and this red one is the critical one. Okay, this is the highest one. So to check the values, I'll show here values and legend also. Okay, it will show you in the legend form. You can see the force, the highest force. Okay, let me change it to maybe, if I change it to newtons, no, kilonewton is better, right? Yeah, yeah, okay. So here you can see the FZ, the reaction forces. Okay, and okay, let me just click here, and from exponential change it to fixed and click on OK. Yeah, now you can see the actual value, which is 251.81 kilonewton, and the FZ which is at node 24, okay, which is 193.77. You can see the values also here, 193 and 251. Okay, similarly if I go to the forces, let me zoom it a bit. Now if I go to the forces, I'll go to the front view of the model, I'll close this and I'll go to the initial view. Okay, I'll undisplay this load, undisplay. Yeah, now for that, to check the forces, I'll go to forces and beam forces and moments. Now whenever you are checking the beam forces and moments, remember always these forces are the value that you are seeing, maybe FZ, FX, MY, MZ, like that. These things are totally incorporated to the local axis of the members. Okay, this MY, XYZ, this is nothing but the local axis. Okay, do not consider about the global axis while checking the forces and moments of a particular element. Okay, and again, the moments of the beams will be always about the major axis or about the axis, and the forces will be always along the axis. But in case of elements, maybe in case of slabs or element type of elements, in that case the moments also will be along the direction. But in case of beams, it will be about the axis. Okay, so as the direction of bending, this direction is downwards, right? Fz. So it is bending about which axis? Bending about which axis? Let me see that local axis of the member. Let me go to the isometric view and let us turn on the local axis. Here, if I go to elements, can we have local axis here? Apply. Here you can see. If I close it, you can see here this particular direction is nothing but the y direction. So the bending moment that we'll be checking, it will be about the y axis, right? So this is the major bending moment, right? So we'll be checking the my. Now load, for which load you want to select, you can always select from here. And now here, if you want to click the value and the legend also, you can also see the deform shape. Apply. You can see the deform shape and the moment values in terms of the legends. Okay, so if I go to the the front view, you can see the highest moment we are getting in this area, which is 53.75, right, in the mid span. Okay, now if I do not deform, you always, right, you can also see the deformation separately. You can see the forces, maybe the Fy or Fz. Okay, let me write it, make it Fz. You can see the forces or different any value. If you want to check the animation, if you always click on animate and click on apply, and if you click on here record, it will be showing you the animated shape. Suppose I want to check the deformation also, so again right click on record, so you can see the deformation. Maybe for the my, apply. Actually, Mr. Ahmed, this session is not about the bridges actually. Okay, in this session I'll be showing you only the 2D and 3D model, actually 2D and 3D frame. But and I'll also create, I'll also make any live session maybe in future, in which I'll be showing you how to check the design of elements there. Okay, bridge elements there. You can see here now. You can see the stresses or any diagram, maybe diagrams and maybe define diagrams. So now what type of diagram you want? Maybe DZ and display option, sorry, displacements. Obviously we want displacements along DZ. Okay, add. So these diagrams, actually it will be added in the report, not here, I guess. Yeah, if you see the deformation, deform shape or displacement contour, so always you can see the displacement contour. Okay, DZ. Suppose I'll be checking for soil pressure. Let me go to earth pressure, and the earth pressure, I do not know, maybe along DYZ. Okay, or maybe DX. Apply. You can see the earth pressure. Obviously in the DX direction we had the earth pressure, so in these columns, or you can say in these elements, we are having the earth pressure, right? And for this also you can see the animated shape. You can see how the earth pressure is acting, and you can also check whether this is the load that you have assigned, whether it is correct or not. Okay, so this is how you can create a 2D model. Fine. And similarly, let me just stop this. Sorry, if I close this, yeah. Similarly, you can do for 3D also. Now, if I save this and create a new project, just give me 1 second. Let me reopen the. Okay, just give me 1 second. So now, just give me 1 second. I'll be opening it again now. Yeah, yeah. So I'll go to a new project. Here, I'll create a 3D frame in the similar way. For that, I'll go to structure. Is it visible? Yeah, okay. So I'll go to structure and RC frame and box. Now here I'll create a 3D 3-dimensional frame. Okay. Now when you're selecting this 3-dimensional frame, you will have this option to create a wing wall also. You can see this wing walls to retain the soils, right? So I'll add this wing wall actually. Now if you want to make this structure not flat, maybe with some curve, you can always define the curvature actually. You can always define the angle and it will be a curved structure. Means the top of the structure will be curved. Okay, there will be some gradient here. You can say angle here. Fine. So for this, I'll not create this one. I'll add the wing wall with 450 thickness maybe. Yeah. And this size of plate element, I'll select 0.9 or maybe 1 meter. Fine. The span again, I'll be creating a span similarly, two spans of 6 meter, maybe 2 at the rate 6 meter. Okay. Skew angle, if you have skew angle, you can always give this, but I'll not give this now. I'll make it 0. These values again you can make by yourself. Here maybe I'll keep it 7. I'll keep it 300. It will be 1.5. Here I'll make this as 0.09 maybe, or 0.1. Okay, 100 mm. Fine. I'll also make this 0.1. I'll make it 8. Sorry. Here also I'll make it 1. Will be 3. I'll make it 1. Okay. So I'm just changing these values a bit. 0.48 or maybe 0.5. I'll make it 0.5. 0.7. You can always play around with these values actually. Yeah. 8. Yeah. Fine. Okay. So I have changed these values. These are same as the 2D one. You just have to define this. Okay. Now if I go to transverse, similarly you have these 3 types. I'll be selecting the first one. Now okay, 15.24, maybe it will be 15 now, because this one I'll make 2 and the other one I'll make 2. Okay, and I'll make these as 4, 5. Okay, so the total we have created longitudinal, if you see here, two spans of 6, right? And the transverse direction, if you see here, okay, this was longitudinal direction, right? Two spans of 6. So in the transverse direction, if 4.9 meter is gone, right? 4.9 meter, 4.9 meters. So this B5 will be, we need to change this, right? What will be the size of this? Let me make it 1 only. B5, this value will be 12 minus 2.9, right? 12 minus 2.9. So what will be the answer? It will be 9.1, right? 9.1. Same as before. Now you can see the similar things. We have the springs, all this. One second. And if I go to loads, then again you can create the load combinations as per ISA 6 2000. You can define these densities, the barrier, okay, the side work. You can always define the thickness of the side work, maybe 300 I'll consider now. Okay, the settlement and the temperature that I have explained, same as the 2D. Okay, now if I click on OK, you can see I have created this. As I have created two spans of 6, so here it has created two spans of 6. Now this particular area, if I cancel it, this particular area, if you see here, the section is bit larger, right, than the sections here. Now why these sections are larger? Because what it has done, it has considered the section which is equivalent to the haunch, because there it will be having haunches, right? So the section which is equivalent to the haunch, it has created the section like that. You do not have to create by yourself, it will be doing automatically. The section which is equivalent to the haunch area, okay, and you'll be designing, or you can get the reinforcement for that haunch area from this element. Okay, similarly it has assigned the loads on this. If you go to works, and here you can see, okay, we have not created any material, right? So let me create one material, undefined. Here you can say assign, maybe do we have define option, properties? Yeah, so concrete, actually we should do it in the very beginning itself. So maybe M30, click on OK. Okay, and it is assigned automatically to the structure. Okay, because we have selected this in our module. And yeah, now you can see here the loads. If you see the earth pressure now, this where we have earth pressure. Yeah, here, right click and display. You can see the earth pressure is assigned to the wings and to the walls in the other direction also. Right, let me make it, sorry, let me make it transparent. Yeah, you can see the how the earth pressure is assigned, triangular shape, and also the earth pressure is assigned to the wing walls, and this is also in triangular shape. Right, is it visible? Let me take one particular wing wall so that it will be visible to you properly. Let me undisplay the loads. Okay, and go to the front view. I'll select specifically maybe top view. I'll select this wing wall and click on active. Yeah, yeah. So now if I go to this wing wall and pressure loads, you can see here also the earth pressure is assigned as in a triangular shape, right? So just think, if you are defining by yourself, suppose you are assigning all this by yourself, selecting all this particular element, it will be very critical job for you, right? Maybe in a small structure it is okay, but in a major structure, or maybe a large, if the size of the structure, you can say, if it is large, so in that case you may get some issues, right? So in Midas you do not have to face these things. Okay, you can define these things automatically from the wizard. That's why this is the beauty of the wizard, or you can say the structural wizard that Midas have. You just have to define the parameters, and automatically it will be assigning wherever it is required. Okay, the same thing we have if I click on the active all, and if I select this particular wall, maybe, and display this, and here if I select this particular wall, okay, and active, okay, here also you'll see the pressure load play similarly. If I go to the front view, yeah, sorry, front, you can see the pressure load assigned on the wall and how it is changed. At the top it was 8.1, and at the bottom we have the maximum value. Fine. Is it clear to all of you how we can do that? Now if I active the whole structure, you can also see the static crowd loads, maybe this one display. We have this crowd loads. Actually our structure, this is the direction, this is not the direction, okay. X is the direction of our structure. Let me save it to maybe 3D frame demo 2. Yeah, so here we have the crowd loads of 4.8 kilonewton. You can change it to 5 kilonewton also, okay. So and then we have what we have, the pavement load. Let me see where we have the pavement load. Pressure, maybe display, sorry, pavement loads will be there, yeah, maybe here, pressure loads, yeah, display. Here you can see the pavement loads on the slab, okay. The dead load, under the dead load we have this pressure load, right? So this pressure load is nothing but the pavement load, you can see. And if you see the self weight, obviously it will be there, but you cannot display because they assigned automatically, right? So this is how what you can do. You can create a 3D frame also with wing walls, and you just have to run the analysis now. Let me undisplay this, and similarly if I go to results, sorry, here we have this perform analysis option. Now it will perform the analysis in just a few seconds. Yeah, now it is done. Let me go back to the initial model here, okay. Now if I go to results, and similarly you can see the forces. Now in that case we need the plate forces, right? So plate forces, and as I have told you that in case of plate, the moments will be along the direction. So let us see the local axis of this plate elements. Sorry, I used to forget actually. Okay, so if I go to display here, display options, sorry, not here, and we have these elements, and we'll be checking this local axis, apply. So the local axis for this plate elements, if you see, this direction is x direction, right? So we'll be checking the movement along x and y, okay. So let me turn off this, and if I go to moment, maybe mxs, right, and click on apply. What the things we need the legend and values, and click on apply. So you can see here, now this contour, maybe I'll turn off the value, apply, yeah. So this contour is for dead load and the pressure load. That if I change it to maybe crowd load, and if I apply now, it will be changed. Okay, and you can see in the legend format, you can see what is the values that you are getting in different areas. Okay, if I change it to MYY now and click on apply, you can see the load, the moment along MYY. Now this is the moment for which you will be providing the distribution reinforcement, right? And maybe the forces, again you can check the forces FYY, FXX, whatever you need. Maybe I'll be checking the FZ, where we have FZ. We do not have FZ, right? Maybe force maximum. Yeah, now you can see where we are getting the maximum force. You can check the shear VXX. See, in the support sections we have the higher shear, right? If you see the Vmax, it will show you these areas only. Yeah. Is it clear? Yeah, if you do not want horns, no, actually what it consider in case of this kind of structure, okay, in case of the, you can say what it is, culvert structures. Okay, so we do have horns. Actually we need to provide the horns to reduce the shear in these corners, right? So if you do not want to provide horns, you just have to select these elements and change the section. You can always select these elements as I have showed you. If you go to the top view of the structure, okay, let me just close this and okay, go to the initial model. Suppose I want to change the parameters of this particular element, so you just have to select this, maybe like this. Okay, now you just have to assign the property that you want. How? Suppose here some thickness is provided, right? You can always understand that this thickness, you can see 0.85 is the highest thickness, right? So you always change it, properties, and you can change the thickness from here. So this horn section will be changed, right? Means this section sizes will be changed. Okay, everything is possible here actually. Okay, now if I go to the results again and the isometric view, yeah, unselect, yeah. Now what you can do, so yeah, everything I have already shown. Like you can see the stress, maybe beam stress, plane stress, okay, plate stresses will be checking. Okay, stress at top and bottom, whatever you want. Okay, maybe the maximum one, apply. You can see the stress, though we do not need this now, but we can check always the stresses here. Maximum shear, you can see. Okay, so this is how you can analyze a 2D and 3D frame. You can always, I have also shown you how to create these things. You can always create using the nodes and beam elements also, right? Just if you are creating this particular face, and by selecting this element you can extrude it, right? And in the other side you can also create the wing one, right? So very easily you can create by yourself also. If you do not want to use the structure wizard, so you can create this by yourself. And if you go to this load, you can always assign different kind of loads, like the static loads. If you go to static cases, see there are different static cases defined here, so you can define by yourself and you can assign these to the elements here. We have the self weight, okay, then we have the element load, line load. Okay, so accordingly, if you have a 2D element, every load will be line load, right? In case of 3D element, maybe we have this plate, so it will be element load. So yeah, from here you can always define, but as we have this easy option to create the structure and assign everything in one go, so you can always create these structures by you like using this structure wizard. Any change you can always use the tree menu, select the particular element or particular load you want to change and just change the value that you want to. Okay, so yeah, this is all about our today's live session. At the end of this live session, I just want to uh, tell you something that from September mid, maybe September 15th and September 10th, actually we are starting new courses in our mobile app, that is the Android application. Okay, one course is this one, Advanced Programming Bridge Superstructure Design, RCC and PAC, using Midas civil and manual approach. That means the manual calculation and what are the different approaches that you need. That means that from the basic and also the Midas civil. Using the Midas civil, you will be designing the structure, which is our bridge superstructure. Okay, so these are the contents. Actually, this is the gist of the content. You can always understand that inside this there will be a lot many. So if you see the basics of bridge engineering, actually in our app already one course is running, which is bridge superstructure design using manual method and also using the STAD and ASVD. Okay, so that was the beginning of our bridge design. Now there are many queries on Midas, that's why we have launched this course also. In that case, the basic of that course, that means the basic of bridge design will be always explained. Okay, initial stages, all the basics will be explained. After that, you will get the introduction of the Midas civil software. You already have got in YouTube, and also you will be getting in the course. Then how to model different type of bridges. Okay, the how to define time dependent properties. What is time dependent property? That means the due to creep and shrinkage, the material strengths used to get reduced, right? So this time dependent properties, how you can define, it will show you that in the course. You will get this particular part. Then different type of loads like static, pre-stress and moving loads. Moving loads, if you see here we have this moving loads option. Okay, now suppose I want to assign define moving loads as per IRC. So we have India. So it is asking that the analysis result. Okay, let me click on define. Now you can define the traffic lanes. Maybe you can see the traffic lanes as per the code IRC 6. Okay, then you can define the vehicle, what type of vehicle you want. You can see class A, 70R, 40R. And if you want to make rail bridges, then you can select the IRS bridge rules. Okay, and as per the IRS code, you can select the vehicles from here, right? So these things, every concept will be explained in the course. Then the projects that you will be doing, we have the RCC frame and slab design, RCC box culvert design that I have not explained properly, but you will be finding here in the course. RCC T girder analysis and design, PSC I girder analysis and design, PSC box girder analysis and design, and latest grillage modeling, how we can create the grillage modeling. The design will be as per the limit state method, and the codes that will be used, which will be IRC 6 and IRC 112. This IRC 22 will not be there actually, because this is for the sections for the different type of structure. This IRC 22 will not be used, but IRC 6 and IRC 112 will be used. And then the assignment projects will be there, which is the IRC box culvert design and the PAC box girder design. Okay, so these two projects you will be doing. You can also do these projects also, but as the assignment, after the sessions you will be assigned to these particular projects, and after completion of these two projects, will be issuing the certificate and the project completion letter as well. Okay, that you have done these projects using the manual calculations and also using the Midas software. Okay, so it is not like you will be doing everything in manual calculation, but whatever is required to do manually, everything will be shown here. Okay, and every resource like the codes and the calculation process, everything will be shared in the app itself. Okay, so this is one course. Who are interested in bridge design, they can always join this. And if you want to join this, in the description box we have the links. You can always join, check the link there for the course, and I have already given the link for the for our group also, which is our Telegram group. So you can join there, you can ask your query. And another course that we have launched, this is nothing but the course on buildings. Okay, so this course is a combined course which will including ETABS, SAFE and the manual process. Okay, and it will be covering the RCC building and foundation design, and we'll be taking a structure having basement, okay, and it will be kind of a mid-rise structure, okay, not like a box shape, because we understand that people need the critical situations so that they can understand that what they need to do in the critical situations, right? So already one course is running on ETABS. You can always see the video on my YouTube channel. I have posted two videos on of this particular course, right? The total class of two classes, so you can always see what type of structures we are designing there. So the total content, if you see, it is huge. It is huge. You can see here every single thing from the basic introduction, the structural systems. You need to understand different kind of structural systems. Then what is the process of mathematical modeling? Okay. Then different kind of loads, including the gravity loads and earthquake loads and wind loads, both dynamic and static and dynamic. In wind load also, I'll be showing you how to define the dynamic wind load as per the code IS 875 using the gust vector approach. Okay. Then different modifications and checks as per the Indian code and also international code. The design as per IS 456 and IS 13920. Okay. The every element design will be shown here. And this is not like only software. You'll not learn only the tool. We'll be explaining the concepts also. We'll be explaining what is the manual approach and how you can check the design manually also. Design optimization is very important, because suppose you have provided our design section in your terms, it will be okay because this is past. But in terms of the cost of the structure, maybe this design is not appropriate. So we'll show you how to optimize the sections. Then the safe course will be starting. Okay. This particular course, if you see here the duration, this particular course will be having 20 to 25 lectures, and every lecture of 2 hours, so it will be around 35 to 50 hours actually. Maybe in between all the lectures do not need 2 hours, so I have written here 35 to 45 hours it will be. Okay. And live sessions will be starting from 10th September for this particular course. Okay. It will be starting from 10th September, and in between we have Navaratri. So after completing the ETFs course, there will be a gap of 1 week, I guess, and after that we'll be starting the SAFE course from 20 to 22nd October. Okay, so just this gap is due to the Navaratri holiday. So after the Navaratri, again we'll be starting from 22nd of October, and it will be about the SAFE for the foundation design. Okay, the timings will be Friday, Saturday and Sunday, 9:30 p.m. to 11:30 p.m. Indian time. Okay, so if you see the foundation design in SAFE, where it is, yeah. So these are the basic foundations. Obviously, we'll be designing the isolated footing, the combined footing, the eccentric footing. Okay, the foundation with strap beam. Okay, and raft foundation, pile cap. This is the critical thing actually in if you are designing in SAFE. So we need some manual calculation also. Even in case of raft also, we need some manual calculation. Okay, this particular thing is very important. Design of punching. Sometimes the software gives the absurd result, so we need to change or we need to do it manually sometimes. And the concept of drop. Okay, how to okay, after designing everything in SAFE, there is one particular concept which is very important. Maybe you will not find everywhere, which is the soil structure interaction. Okay, SSI. So I'll show you how you can do the soil structure interaction after completion of the foundation design. So how you can define or model the ETAB foundation ETABs. Maybe some of you already know this, but after modeling, how to check the observation, like how to check what are the changes in the model and what is the approach of doing the soil structure interaction in ETABs. Okay, and using the SAFE and ETABs model. Okay, so I'll show you in this particular course. So every advanced topic, starting from the basic and maybe the construction sequence analysis, the stability checks, the dynamic wind analysis, okay, the response spectrum analysis, every single thing, the accidental torsion and how to check the torsional irregularity as per Indian code and as per UBC 97. Every single thing, response reduction factor, what is this particular term and why we should consider this. Okay, So every single thing will be explained in this particular course. This course will be around, as I have told you, it is 20 to 25 lectures, including the foundation, and the total duration will be 35 to 45 hours. Maybe we may extend this as per the requirement. And I'll also share all the resources, the CAD files, the Excel sheets. I'll not actually use here. If I use, I'll be showing you how to create the Excel sheet. I'll not share the Excel sheet, to be frank. Okay, so I'll show you how to create that Excel sheet for some critical matters. Maybe the dynamic wind analysis, I'll be sharing you the Excel sheet also. Okay, but the simple Excel sheets, if I use, I'm not going to use any Excel sheet except some critical cases. But if I use, I'll be showing you how to create the Excel sheet also. Okay, but surely for critical cases like the dynamic wind analysis, I'll be sharing you the Excel sheet also. Okay, so this is what our course is. Two courses we have launched, Midas Civil. It will be starting, the tentative date for this particular course is September 15th. Okay, the tentative date for this course will be September 15th. Timing will be the same as our previous course. It will be 6 to 8 Saturday and Sunday, and in between, if we suppose we'll be talking, or we'll be talking about with all the participants, and if they agree, then maybe we'll increase in some weekdates also, maybe 3 days a week. Okay, so we can do that. These changes we can make by considering the situation. But the tentative date will be 15 September. Timings will be Saturday, Sunday, 6 to 8 p.m. Indian time. Okay, so if you want to join, or if you have any query regarding these courses, you can always join our Telegram group. You can comment also. Okay, you can always comment also here in my YouTube. I'll try to answer you. Otherwise, you can always join our Telegram group, and you can ask the questions. Or if you have not downloaded our mobile app, please download the mobile app, which is Illustraca. You'll find it in Google Play Store, and the link is also there in our channel's banner. And the right hand side corner, you will find here, somewhere here in the right hand side corner, the link for the app. So you can download this app, and in the app also you'll have the chat option, so you can always ask your doubts there. Okay, so this is it for today. If you guys like this session, I'll be conducting this kind of sessions on different kind of softwares and different kind of tools, different concepts. I used to try every week, but it is not possible for me to conduct these sessions every week, but I'm trying my best to conduct as frequent as possible. So maybe in few days I'll be conducting another session live on different topics. Okay, and please do let me know if you have any confusion, or if you have any doubts in any of the topic. I'll try to make videos on those topics also. Okay, so yeah, this is it for today. Thank you all of you for joining this session, and yeah, so please do let me know your opinion about my live sessions. If I need to change something, or I need to make anything new there in the live sessions, so I'll try to impose those things in my sessions. Okay, thanks again. I'll be signing off. Thank you.